2x minus 0.3x natural log x. And I always write thousands for the profit and x thousands of candles. Okay, so it's given, the formula is given to us. The marginal profit, this is the name of it. It's the first derivative, but it's called marginal profit. I was just going to say C prime of x will be the marginal cost, and R prime of x will be the marginal revenue. Not relevant here. I just was talking about the notation. And so in part A, P prime of x, I differentiate this and I get 2. Now I have to be very careful, negative 0.3, but this is a product. If I don't realize that, I will never get the correct answer. So please remember how we differentiate a product. The first function prime is 1 times the second function plus the first function and times the second function prime. And I simplify. So the simplified form is 2 minus 0.3 times natural log x minus 0.3 times 1, because I want to combine these two into 1.7 minus 0.3 natural log x. This is the final form for part A. In part B, but let's stop for a moment. Any questions here? Let me know if something needs to be clarified.
I didn't get that.
When you say that, you mean?
No, how you get I think that is.
You're talking about from here?
Yeah.
The first function prime is 1 times the second function plus the first function times the second function prime. X times 1 over x is 1. I simplify x. Was that the question, Tess?
Yeah, but the x is the variable x or the times?
Do you remember the natural log x, the derivative of natural log x?
Next to 0.3. That is.
What is the derivative of natural log?
No, that is 1 over x.
How much is x times 1 over x?
I'm not asking you that. I'm sorry.
Okay.
But 0.3, is that x or times? That's what I'm asking you.
Every time we differentiate a constant times a function, the constant stays in front, and I differentiate the function. The constant is outside.
The question itself, it's multiple or the variable x? I'm confused with that.
So ask the question again, please.
0.3, is that x or 0.3 times the natural log?
Very good question. Very good question. So let's take a look. 2 times x times y. Does this mean 2 times x? Does it mean 2 times y? Does it mean 2 times x and 2 times y? What does this mean? Let me give you a numerical example. 2 times 3 times 6. Is it 2 times 3 and then 2 times 6? You're confusing this with this, where I have to distribute. This is not the distributive law. This is a product. You multiply from left to right step by step. 2 times 3 is 6. 6 times 6 is 36. You're not using the distributive law here. So negative 0.3 times x times natural log is this. It's not this. You're not distributing -3. This is not plus or minus. We use the distributive law only if we have two operations, product outside and sum or difference inside. Is this clear now?
It's clear, but still my question is, that is multiple, or the variable x next to 3.
So when we
confusing
say -0.3 x natural log x, we mean product. Otherwise, we will have a different operation symbol. If I don't have plus or I don't have minus, it has to be a product. That is carved in stone. If I tell you ABX, I mean A times B times X. That is carved in stone. Otherwise, I have to say A plus BX. But I'm not saying that here. I'm saying -0.3 x natural log x, which immediately assumes it's a product. So you have this situation, not this situation. So -0.3 stays outside, and I'm applying the product rule on this quantity. First function prime is 1 times the second plus the first times the second prime. So then inside I have natural log x plus 1. I distribute now because now I have to use the distributive law because now this is plus or minus, right? -0.3 times natural log is here, -0.3 times 1 is here. 2 minus 0.3 is 1.7, and then I copy this term. Is this better? You may be muted, Tess. I can hear you.
No, I'm fine. I'm good. Thank you.
But did I answer your question, or it's still?
Yeah. Definitely. Thank you.
Okay, so just remember, when we say ABX, we only mean product. But if I say A plus BX, then I mean A plus this term, which is a product of B and X. We only distribute if we have two operations. Here we don't have two different operations. This is all product. But if we have two different operations, then they have to be definitely multiplication outside and sum or difference inside. Then I will have, in this case, I will say 9 times 2. But if you want, this will be 6 plus 12. 6 plus 12, or minus, whatever I want. So that's why here we do not distribute, because this is one product, one term. Where are we? So in part B, they're asking us to find P prime of 150. So in B, P prime of 150, and we have 1.7 minus 0.3 natural log of 150, but I have to make sure. So 150 is given in thousands, but it has to be in thousands because that's what the formula works with. This is in thousands and this is in thousands. So when they say 150, they mean 150,000. No one can do this by hand. I have to share my screen. And I need to see, okay. So 1.7 minus 0.3 and times natural log of 150. And the answer has to be in thousands as well. So when I click enter, I get this multiplied by 1,000, 196.8. 196.8. Okay? Now, what is the measurement unit? You have the other option of writing it as 0.1968, but then it would have a different measurement unit. Which both are okay, as long as we fit the correct measurement unit.
Dollar per candle.
So first of all, it's P prime. It has to have two measurement units, one coming from P and one coming from X. Same thing here. One coming from P, one coming from X. So if we use this notation, we only have to say dollars. But if I use this number, then I have to say thousands. Now, what do we have here? What is the measurement unit of this? So it's units, right?
Yeah.
Per unit. Not, sorry. I got a new whiteout and it's leaking all over the place. That's what it does when it's new, I guess. Per unit. Any questions on this? Can be estimated and explain what this number represents. So this is dollars per thousands of units. That's why I meant to say units, thousands. Because we plugged in thousands. So it's dollars per thousand, so $196.8 per thousand units, or 0.1968 thousands of dollars per thousand of units. So what does this represent? How will you put it in writing? So let's put it in writing. So which one do you want me to put in? There is no need to put both. You want to put this or you want to discuss this? It doesn't matter. Choose one. Okay, so let's say this one. So 0.1968 thousands of dollars per 1,000 units. That's better to write like that. Represents the rate of change, because it's a rate of change. The rate of change of profit with respect to 1,000 units produced, sold. Produced and sold, of course. In part C, how many candles in thousands should be sold in order to achieve a marginal profit of $7.50 per 1,000 candles? So what do? We are given the marginal profit. They are telling us it's $7.50. And that equals 1.7 minus 0.3 natural log of 150. How do we proceed here? So we have to be careful here because I just realized that they're trying to trick us. So for this formula, we should use 0.750 here. Because it says a marginal profit of $7.50 per 1,000 candles. Okay? So how do we, of Of course, it's x. Why did I copy 150? Ah, because I copied it from there. I understand what I did.
7 and then divide by 0.3.
So, yes. So what do we do? What is the first step?
Subtract by 1.7, then divide by negative 0.3.
Right. So, how much is this? 1.7 minus
95.
negative
95.
0.95 equals negative 0.3 natural log x. Okay, and what is the next step? We divide by negative 0.3, so then we have natural log x, 0.95 divided by 0.3. We have to plug this in the graphing calculator. Let me share. And let's see what we get. And can I use this? No, I cannot use that. So 0.95. Oh, let's just change it. I don't want to do it in 2 steps. So this is equivalent to e to this number. So x equals e to this number. 0.95 divided by 0.3. So then x is, okay, so clear. I want e. Where is my e? I found it. 0.95. Your sophisticated calculators will work without parentheses, but if you don't have one, I have to show the correct entry. Okay, so 23.728, which is units, but it has to be in thousands. So 1,000 units. Or you say, or x equals 23728. 23728 units, multiplying by 1,000. Good. Other questions? Is there anything else we want to look at before we start chapter 3? Very good questions. Thank you so much. Thank you so much.